Everyone, welcome to section 3.4. In this section, we are going to be talking about the conditional and related statement. So the conditional and related statements. What is the objective of this lesson? The objective is to find the converse, inverse, and the contrapositive of a conditional statement. We wish to translate conditional statements into alternative forms. We wish to recognize the structure of the biconditional. So what is a biconditional statement? We wish to summarize the truth table for compound statements. So let's get started. Let's talk about the original statement that we've talked about in section 3.3. That's the P, if P, then Q. What does the converse mean? The converse, you're just switching Q and P. So if Q, then P. We wish to find the inverse. The inverse is you're negating P, then you're negating Q. So if not P, then not Q. And the contrapositive is if not Q, then not P. So we're going to be talking about conditional statements, the converse, the inverse, and the contrapositive. So let's look at the following. We wish to determine each of the following given the conditional statement. If I'm running, then I'm moving. So if P, which is running, then Q, then moving. If you want to find the converse is Q, then P. If I'm moving, then I'm running. The inverse is you're negating P and then you're negating Q. If I'm not running, then I'm not moving. And then the last one, the contrapositive is not Q implies not P. That would say, if I'm not moving, then I am not running. If not moving, then not running. So let's look at that in India. And if I'm moving, then I'm running. If I'm not running, then I am not moving. If I'm not moving, then I am not running. That's converse, inverse, and contrapositive. Equivalence, a conditional statement and its contrapositives are equivalent. So let's show that. Also the converse and the inverse. So we want to show that the conditional, so the conditional means P implies Q is equivalent to the contrapositive. So what is contrapositive? Not P implies not, oh no, contrapositive is not Q implies not P. So let's show that on the truth table. So we have a P, a Q, and then P implies Q. And then we have P, Q, not Q, not P, and then P not Q implies not P. So when we have our truth table, so T, T, F, F, and then T, F, T, F, T, T is T, T, F is F, F, T is T, F, F is T. Now here we have same old, T, T, F, F, T, F, T, F. Not Q would be F, T, F, T. Not P is F, F, T, T. Now you have F implies F is T, T implies F is F, F implies T is T, T implies T is T. So look at the solutions, T, F, T, 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 F, T, T. They are equivalent. And we show that by using the truth tables. For a conditional statement, not P implies Q. The converse of that conditional statement would be you just switch them. Q implies not P. The inverse, so you begin with this original statement. If you want to find the converse, you want to switch. The switching, it's the converse. If you want to be the inverse, you negate the statement. So it would become not P is P, and then Q, not Q would be not Q. The contrapositive, all you have to do is switch them and negate them. So this is switch plus negate, negative or negate. So you switch them and then negate Q and then implies not P. Now let's look at the conditional. The conditional has some translation. So if P then Q, if P then Q, if P Q, P implies Q, P only if Q, P is sufficient for Q. And then again, we had P is the antecedent and Q is a consequent. We talked about that. All P are in Q and then Q if P. Now we want to reorder. So we want to say if P then Q, you'll starve if you don't eat, go to the doctor only if the temperature exceeds 101, and everyone at the game has a great time. So we're looking for the conditional. Then if P then Q, remember you can change that. If you do not eat, then you'll starve. So you changed it to a converse. If you go to the doctor, then your temperature exceeds 101. If you're at the game, then you had a great time. Okay, so we can split if and then. So you'll starve if you don't eat. That means if you don't eat, then you'll starve. Then go to the doctor only if the temperature. So that means if you go to the doctor, it's because your temperature is exceeding 101. Now let's look at example 4. Let P represent a triangle that's equilateral. That means that all the sides are equal. And let Q represent a triangle that has 3 sides. So if you are an equilateral, then it has 3 sides. You can say a triangle is equilateral if it has 3 of equal length. So if P then Q, a triangle is equilateral only if it has 3 sides. So let P would be an equilateral triangle and then Q would be equal length. So if P then Q or Q then P. You can always translate a triangle that has 3 sides of equal length and then defining an equilateral triangle. So if P then Q. We also have something called a biconditional. So if and only if. This is P if and only if Q. So it has to go both ways. So P implies Q and Q implies P. So this is a double conjunction. What we have to do is we have to look at it by a table that conditions both P and conditions Q. So let's look at the truth table. So when we have TT, T implies T is a T, TF is F, FT is F, FF is T. So they must match. TT or FF, that's the only time you will have a biconditional statement to be true, when both of them are true. True, true, or false, false. They must have the same value in order for you to have a biconditional. So let's look at the definition. Determine whether each conditional statement is a biconditional. We want to check if it's true or false. So 6 plus 8 equal 14, that's true. If and only if 11 plus 5 is 16, T. Yes. So T, T, double T, it's a T. That's true. Now, is 6 equal 5? No. F, if and only if 12 is not equal to 12. This is actually true because here we have, oops, sorry. 12 does not equal 12. Well, no, 12 is equal to 12. So this is false. So F and F is true. Mars is a moon if and only if Jupiter is a planet. Well, first of all, Mars is a planet. So this is F and this is true. F if and only if T, no. That's false, right? Because Mars is a planet and Jupiter is also a planet. But the statement is false. So F if and only if T is a false. T implies T biconditional, yes. F and F, yes. And then you want to talk about the summary of what we discovered and what we talked about on this section in this chapter in general. You have the negation of P of the true value, which is the opposite of P. P and Q is a conjunction. P or Q is a disjunction. P implies Q is a conditional. P biconditional with a Q, so if and only if Q is biconditional, it's only true when both P and Q have the same truth value. So you have basic conditions. It's only true if and only if P and Q are true. The only false is when P and Q are false. The only false is when P is true and Q is false for the conditional. And you only have true when P and Q are true. And with that finishes our section 3.4. Thank you so much. So make sure you review the material on chapter 3. We will have a test on coming up this week, so please make sure to review the content. Thank you, and I'll see you guys next time. Have a good day. Bye-bye.